Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher, and today we are going to do actually you can say two or three chapters. So basically, chemical equilibrium and ionic equilibrium are in the same thing, that is equilibrium only, but ionic equilibrium is itself a very big topic. So I can say that today we are going to do top three chapters, that is chemical equilibrium, ionic equilibrium, and thermodynamics. Okay, so I know you guys are a little bit scared of this topic. So basically, now the thing is that these three chapters, or I would say chemical, ionic, and thermodynamics, it has a lot of formulas, right? So revision is very important when we are going to do the questions of this, right? Okay, so everybody, let me know in the chat box if I am audible and visible to all of you. And shall we start the class or not? Okay, so today we are going to do a fast track. In a fast track way, we are going to do the revision before that, before the questions. So first thing is, firstly, I'll be doing, so I have already prepared my handwritten notes for you, right? To save the time. Yeah, okay. So if I start writing it over here, then it will take double or triple the time, right? So that's why already the notes are here that will be available to you on Vedantu J English and also on the Jungle Box, right? Firstly, we are going to revise chemical equilibrium and ionic equilibrium in a quick way, and after that, or we can do one more thing. Firstly, we will just revise chemical equilibrium. We'll do the questions of chemical equilibrium, then ionic equilibrium, questions of ionic equilibrium, then thermodynamics and thermochemistry, questions of thermodynamics and thermochemistry. Okay, yes, everybody, shall we start? Yes, sir. One thing for reversible change, is it correct? Beta, firstly, let us do this, right? After that, you can ask the questions. है ना? Okay, chalo. Now, let us start it. Let us start it. Let us start it. Right? If you have some specific questions, right, you can definitely ask me on my Telegram channel or on official Telegram channel of Vedantu J English or on t.me/Diksha Kaushal Chemistry or on Instagram handle Diksha___ Kaushal. You can ask your queries over there if you have some personal queries regarding this question, that question. Okay? Yes. Chalo. Hello, hello, hello. Yes, everybody. How will the lecture, how long the lecture will last? So Harish, as you can see, chemical kinetics, I can't do it like this. Hey guys, this is chemical kinetics, tada bye bye, ionic equilibrium, tada bye bye, thermodynamics, tada bye bye. Not like that. But I feel, I think 8 or 8:30 maximum will finish off these topics. Okay? By maximum 8 or 8:30. Right? Okay. Chalo. Now, let us start, and I want to see your knowledge, or you can say what your answers in the chat box, right? Okay, it should not be like I am teaching here, you are sitting like this. No, I want full energy in the chat box, right? Whatever you actually can recall, just write it down, right? Just discuss it with yourself, right, in the chat box, so that you're able to recall this, remember this in your exam itself, right? So without wasting any time, let us start the class. First is chemical equilibrium. So in chemical equilibrium, the first thing is, it is basically a dynamic, it is dynamic in nature. That means it is changing, but we can say it is still, right? Okay, so for example, some water is coming out of the tap, right? Some water is coming out of the tap, and there is some hole from where it is also going, right? So this is the bucket, or you can say this is the bucket. The water is coming out, and from here, from this particular position, the water is also going. So for you who is only seeing this bucket, for that person the water will be still, right? Okay, they will assume that the water is not changing, there is no coming and going of water, but in reality the water is coming from this side and it is going from this side. So that means it is dynamic in nature. In the same way, equilibrium is dynamic in nature. Now, based on these graphs, the questions are asked. So I'll just ask you which of the following graph is correct or not. I'll just mention this A, this is B, this is C, right? This is again A, B, and C, right? Now, guys, if you see this particular thing, I have written here. So first thing is, if you talk about the rate, right? Rate is same and it should be constant, right? Rate at equilibrium, it should be same and constant. But if you talk about the concentration, it can be same or it may not be same. It's not always the concentration will be same. It can be same, it cannot be same, but always and always it should be always be constant, right? Okay. Now, if you talk about the graph of rate and time and concentration and time, right? For concentration and time, let me know in the comment section which of the following graph are correct or incorrect. If you talk about concentration and time, I told you that concentration should be constant, right? It's not specified that it should be same only. So here the concentration is constant at equilibrium. That means definitely it is the right graph. Here also the concentration is constant. Green represents the reactant side, and green represents the product side, and blue represents the reactant side, right? We know that, right? So here also the concentration is constant. It is not same, it doesn't matter to us, right? Here the concentration is same and constant both. Okay, fine, that is also right. Okay, because concentration is, there is no specificity that it should be same also. So all these three graphs are correct. But if you talk about the rate, now I told you rate, it should be same also. So if I see any graph where rate is not same, here the rate of, this is forward reaction, this is backward reaction. So now the rate of forward and backward reaction are not same. That way I can say this graph is incorrect. If I talk about this graph, is this correct or not, guys? Is this correct or not? If I talk about this graph, here also the rate is constant, but it is not same. At equilibrium, rate of forward should be equal to rate of backward. So that is why this graph is also going to be incorrect. Okay, what about this one? Is this correct or incorrect? Is this correct or incorrect? This is correct. Reason being, this is correct. Reason being, here the rate is same and constant, and it should be like that only, that rate should be rate of forward reaction and rate of backward reaction should be same. So from these kind of things, the graph can be asked between C and T and R and T, right? Now, next is the properties of equilibrium. So equilibrium is dynamic in nature, as I told you that it is changing, but we can't visualize that it is changing. Constantly the reactants are converted into products, products are getting converted into reactants, but overall we will see that concentration is same, right? That means the amount of reactant that is getting converted to product and the amount of product that is getting converted to reactant is occurring at same speed. That is why we say rate of forward and rate of backward is constant. It is same. That is the reason it is actually changing, but to us nothing is changing. So it is a dynamic equilibrium. Second beta, we have rate of forward and backward reaction are equal. Third is from any side equilibrium can be achieved. From backward side also, from front side also, any side the equilibrium can be achieved. Next is catalyst. Catalyst alter rate of approach, right? Catalyst like positive catalyst, negative catalyst, they can alter the rate, but they will not have any effect on the equilibrium constant, right? So they will not change the state of equilibrium, right? That is a very, very important thing about catalyst. And catalyst we will discuss about in detail in chemical kinetics. In chemical kinetics, there is detail of catalyst, right? Next is at equilibrium, Gibbs free energy is going to be equal to 0, right? Okay. Now, next is law of mass section. So from here, the questions are asked, right? So right now, you should have full focus on the screen, right? What I am telling you, right? Now, guys, I'm just going to separate this with the help of a line so that you are also able to understand that what we are talking about here, right? So, beta, first thing is, what is law of mass section? Law of mass section says that the Kc, that is the overall equilibrium constant, is equals to forward and backward. That is equilibrium constant of forward reaction divided by equilibrium constant of backward reaction, right? We know that rate of backward is equals to rate of forward. By this, using this formula, right, we derived one equation that is called law of mass section, and that equation is that equilibrium constant is equals to product raised to power the stoichiometry divided by reactants raised to power the stoichiometry. Right? If I take an example, if you take this example, A, B, B give rise to C, C and D, D. Right? Small a, B, C, D are the stoichiometries. Capital A, B, C, D are the, capital A and B are the reactants. Capital C and D are the products. So if we want to write the formula of Kc, right? Kc will be product raised to power the stoichiometry, C raised to power C, D raised to power D divided by A raised to power A, B raised to power B. Right? If I want to write the Kp of this particular reaction, but for Kp, the important thing is at least one of the reactant or product, that means at least one of the species in this particular reaction should be gaseous in state. If any one of the species is gaseous in state, we can say that definitely we can write Kp here. So it will be Pc raised to power C, same thing. P is a partial pressure here. Pc raised to power C, Pd raised to power D, pressure of D raised to power D, pressure of A raised to power A, pressure of B raised to power B. Right? Now, if you want to write the K of X, X means the mole fraction. In terms of mole fraction, if you want to write it, it is the same thing. Here, instead of partial pressure, you will write the mole fraction. Mole fraction of C raised to power C, mole fraction of D raised to power D divided by mole fraction of A raised to power A into mole fraction of B raised to power B. Right? Now, they will ask you the units here. If you talk about the units of Kc, that is mole per liter delta Ng. Delta Ng is the number of gaseous products minus number of gaseous reactants. Okay? Beta, you are asking me what is Kp? What happened? Huh? All good? Loss of memory or what? Acha. What is this units of, if you talk about the units of Kp, that is going to be atmospheric raised to power delta Ng. Now, if you talk about the units of Kp and Kc, we have seen this is mole per liter. Mole per liter is concentration basically. That's why I have written concentration raised to power delta Ng. We know that Kp, that means equilibrium constant in terms of partial pressure. Partial pressure has the unit atmospheric. So, it will be atmospheric raised to power delta Ng. Now, if you want to see the see, from here also the questions are directly asked. Right? This is a very, very important formula. Very, very important formula from where the questions are directly asked. That is Kp is equals to Kc RT delta Ng. Right? And this will be rarely asked, but still, if they ask you this, you should know the formula here. So, Kp is equals to Kx P raised to power delta Ng. Beta, I have directly written the formulas here. Right now, doing the derivation is of no use to you. Right? So, that is why no derivation I am going to do today. Right? Directly the formula that is useful for you to solve the question that I will tell you. Right? Okay? We need to gain the marks right now. Right? Knowledge, so you had enough time. Right? Okay? So, this is Kp is equals to Kx P raised to power delta Ng. Now, question is, ma'am, in the numerical, what will the value of R, ma'am? So, R beta, you will put 0.0821. Ma'am, this is very tough value. So, to make it easy, what we put here, we put just directly 1 divided by 12. Because beta, 1 divided by 12 is nothing but it is 0.0821 only. So, directly we will put the value as 1 divided by 12 instead of 0.0821, right? So, 1 divided by 12 liter atmospheric per mole per Kelvin. Right, that is going to be the value of R, and temperature is going to be in Kelvins here. Okay, what I have written here, concentration of pure liquid or pure solid is always going to be 1. For example, you take this particular reaction, right? Here we know that this is a pure solid, so that is why we will not take this concentration in the equilibrium constant. It will be Kc is equals to C raised to power C divided by B raised to power B. We will not take pure liquid or pure solid concentration because that will be equals to, that is assumed to be equal to unity, right? Okay. Next is factors on which K depends. From here also very simple questions are asked. Very, very simple questions are asked from here also. So the question that beta they can ask you first is, I'll just write the reactions here. For example, you have some reaction A plus B, A give rise to B. This is the reaction that you have. This is having rate constant K1. Now, if you reverse this reaction, let's say you have reversed this reaction as, B raised to B give rise to A. Now, this is K2. So, K2 is going to be equals to 1 by K1. If you reverse the reaction, right, the equilibrium constant is also going to reverse here, right? That will be K2 is equals to 1 by K1. If you multiply it with N, for example, I am multiplying this equation by N. N raise Na give rise to Nb. Now here I am saying this is K2. Then this K2 is going to be the original K1 raised to power N, right? If I am dividing this by some integer, so this will be 1 by N A raised to power 1 by N B. Okay. So now 1 by N A give rise to 1 by N B. I have multiplied by, can I say I have multiplied by 1 by N? If I say if I have divided by N, I can also say I have multiplied by 1 by N, right? So here K2 is going to be, in this case, K2 is going to be K1 raised to power whatever you have multiplied. What I have multiplied 1 by N. So it will be K2 is equals to K1 raised to power 1 by N, right? Next is if you add something. Let's say you have two equations. You have added A plus B and you have one more equation. Let's say it is, let's take an example. You have one more equation, that is C give rise to D, that is K2, right? Now you have added these two equations, that is A plus C give rise to B plus D. Now this you are saying is K3. Now when you add two equations, then the new rate constant, not the rate constant, the new equilibrium constant is going to be multiplication of those two equilibrium constants of the reactions what you have added, right? If you subtract these two things, A minus C give rise to B minus D. If you subtract this from this, now the new equilibrium constant is K3. Then it will be division, right? So K3 will be K1 divided by K2 because you have subtracted these two things. So that is why they will be in the division. Okay, got it? So that was the factors on which K depends, right? This is a very, very interesting and very important, very simple question are asked here, right? Next is, guys, factors on which equilibrium constant depends. Here we are going to talk about the temperature. From here also theoretical questions are asked and some numericals are also asked. So this is the formula that you need to learn. That is log K2 by K1 equals to delta H. This is a very, very useful formula. Log K2 by K1, delta H is the enthalpy divided by 2.303 R. This is bracket T2 minus T1, T1 into T2, right? This is the formula. Now, if I am saying that this is exothermic, that means delta H is negative, right? Energy is released in this case. Beta, now see this thing. If I am saying that this is negative, okay, always here we are saying that T2 is always greater than T1. Okay? That means T2 minus T1 is always going to be positive only, right? This is also positive because temperature will be positive only. So multiplication of two positive terms is positive only. R is, we know that this is positive. That means for an exothermic reaction, can I say that log of K2 by K1 is going to be negative? If log of anything is negative, we can say that K2 by K1 is less than 0. Because if the term inside that log is less than 0, only then the log of that term will be negative. That means this thing will be negative as well. That means we can say that K2 by K1 is less than 0. That means K2 is less than K1. And this is what I have written here, right? That means here we can say that T2 is greater than T1, but K2 is less than K1. T2 is more, but K2 is less. Can I say T and K are inversely proportional? So in an exothermic reaction, right, as you increase the temperature, the equilibrium constant will decrease. In an exothermic reaction, when you increase the temperature, equilibrium constant will decrease here. That is the logic behind this, right? Now, if they ask you opposite of this, okay, opposite of this, everything will be same, just this thing will be positive. That means for an endothermic reaction, this is also positive. That means log of K2 by K1 is positive. That means this term is also positive. That means K2 by K1 is greater than 0. That means K2 is greater than K1. So that becomes the final answer. T2 is greater than T1 always. Now K2 is also greater than K1. That means when we are increasing the temperature, K, that is equilibrium constant, is also increasing. So we can say they are directly proportional to each other, right? Okay. Now, next is application of equilibrium constant, right? From application, how the questions are asked. Beta, in a very summarized manner, I am teaching you this. Okay? No one will teach you like this, right? Okay? So already I have done a lot of hard work there, right? In the morning, I think by 10:30 a.m. I was sitting in the room and just making notes for you, right? Okay? So first is application of equilibrium constant, right? But application of equilibrium constant, there are three applications basically. First application is the extent of reaction. Whether this reaction is very slow, it is very fast. From here, the questions are asked in a theoretical manner. In a statement-based questions can be asked here, right? Statement-based question can be asked here. Assertion reasoning questions can be asked here, right? So theory-based questions are asked basically. They will give you any value of K, right? They can ask you, it will be a slow reaction, it will be a fast reaction. So if your equilibrium constant is greater than, wait a minute, that should be, wait a minute, little mistake. It should be less than, it should be greater than, okay? So here it should be greater than and it should be less than. And if it is less than 0.001, that is 10 raised to power minus 3, that means the reaction is very, very slow, right? It will hardly proceed, right? If the rate constant is, why I'm saying rate constant, chemical kinetics in my header, if the equilibrium constant is greater than 10 raised to power 3, that is 1000, that means it is extremely fast reaction. It favors the product side. It favors the reactant side. It will hardly proceed. If it is in between, it will be somewhat at equilibrium. Anything can happen over here, right? It will be intermediate, right? If you talk about the direction of the reaction, we predict the direction of the reaction by reaction quotient. Reaction quotient is, what is the difference between reaction quotient and equilibrium constant? Reaction quotient is a general thing, that is product raised to power stoichiometry divided by reactant raised to power stoichiometry at any time. But if you say I am at equilibrium, at that position, reaction quotient will become rate constant, right? Okay. So you can understand this by the simple thing, right? Okay. Okay. So you can understand this by the simple thing. This is QC, this is KC. If I am saying that QC is greater than KC, this is KC, this is QC. Always remember, you need to make it equal. Okay, this is a way of understanding, okay, way of remembering or recalling these things, okay. I'll do in the exam, right? Otherwise, so cramming, so you can cram everything here, right? But you need to have something in your head to remember things, right? So this is QC, this is KC, right? Now, will it be a forward reaction or backward reaction? How you will predict? QC, you have to make it equal. Now, QC has to come backward. That is the only case it will be equals to KC. That means it is a backward reaction. If QC and KC are equal, then we can say it is at equilibrium. If this is KC, this is QC. So to make it equal, QC will move forward, right? That means it will be a forward reaction. Okay, got it? So this is how the prediction will happen, right? Next beta is degree of dissociation, right? So this is going to be very, very useful for you because here we are not going to cram any formula. No formula I'll tell you here. Reason being, because if you cram the formula, you will do the mistakes because every single question will have different formula here, right? Now, firstly, I need to understand what is degree of dissociation. Degree of dissociation is represented by alpha, that is number of moles are dissociated by initial value. Now, this initial value can be given to you. For example, I am saying that let's take is this only. Okay, so this is number of moles dissociated, right, divided by the initial value. Let's take this example, right? A, this is B plus C. Let's say this is the reaction. Okay, this is the reaction. Okay, this is the reaction. Let's say this is okay, this is the reaction. Randomly I have written it here. Initial moles, if something is given to you in the question, let's say they say that the initial moles of A will be given to you. Let's say they say that initial moles of A is 5. Okay? Then you will take it as 5 only, right? But what if they have not given you the initial? In most of the cases, they will not give you the initial moles, right? So if they have not given you the initial moles, you will take stoichiometry as the initial mole. So this is going to be, let's say this is 3, this is 0, this is 0, right? 3, 0, 0. From here, which will be taken out? X amount will be taken out, right? So this will be 3 minus 3x, right? This will be 2x will be formed, 7x will be formed here, right? Okay, 7x will be formed here. This is the case here. Now alpha is number of moles dissociated. How much amount is dissociated? Divided by the initial moles, right? Number of moles, if you want to see the degree of dissociation of A, alpha is going to be number of moles dissociated. How many moles are dissociated? 3x moles are dissociated. Initial moles are 3, right? So degree of dissociation for A will become x only. Got it? Degree of dissociation for A will become x only, right? Now, if you see, ma'am, there is some other question, ma'am. What they are saying, they have given initial moles, ma'am. Okay, I'll write that as well. If they have given initial moles, this is A, 2B, let's say this is 3. Randomly, I am taking one example. Let's say in the question, they have given 5 initial moles. 5 amount of initial moles you have taken, right? Okay, let's take that example. 5 initial moles. If this is 5 beta, initially there was, let's say they are even more clever, hai na? JEE mains paper, yaar, right? They are saying that initially you had 5 moles of A and you had 3 moles of B randomly. That initially you had 3 moles of B. I'm saying, okay, you had 3 moles of B. Now they are saying after dissociation, this and that question they have given you, how you will solve that, right? First thing is, we know that after that reaction, 5 minus of which thing? Which amount will be dissociated? That's 3 into x will be dissociated. Here 3 minus this 2x will be formed. In product side, things are getting formed. In reactant side, things are dissociating here. That's why minus here and plus here, right? Now, if they ask you what is the degree of dissociation, so simply what you will say, dissociation of A will be how much amount is dissociated? 3x amount is dissociated. Initial was 5. That's why it is 3x by 5. Okay, 3x by 5 is the correct answer. Okay, got it? Got it, beta? And to find out the value of x, they will give you certain things there in the question that you will do with the help of question only, that what they will give you in the exam, right? Okay, this is a concept that I have told you, that degree of dissociation, instead of just cramming alpha is the degree, do it this way, right? Now, next is, ma'am, Kc calculation. Now it will be useful for you to understand what I have, ma'am, what you have taught, how that was useful. Now you will understand why that was useful. Now, bacha, firstly, if I talk about Kc calculations, okay, firstly, I am talking about Kc calculations. Beta, same question has been asked in your Kp calculation. Directly the questions were asked and student marked it wrong. Why? Because we, ma'am, crammed the formula. We didn't knew how to derive things, right? Okay, in this particular thing, you have to derive. You have to know the derivation. Only then you will be able to solve the questions. Otherwise, it's not possible, right? Now, any random reaction I have taken, A plus 2B give rise to 3C. It will be very easy for you to calculate any reaction, any Kp, Kc, you can calculate there. Now, always remember, if you talk about Kc, in C means concentration. Concentration is usually expressed in terms of molarity. Molarity is number of moles divided by volume, right? Number of moles divided by volume. That means I have to, whenever I was solving, if I see this, the value of Kc is c raised to power 3, right? B raised to power 2. Beta, I'll just write the value of Kc here. Hai na? Kc is c raised to power 3, b raised to power 2, a raised to power 1. That is the value of Kc. Now, ma'am, we don't have anything like in the exam, they have not given us any value. So how you will derive this particular thing? Right? This questions were, this was the option. This was one of the options in that JEE Mains questions. Okay. So here, what we will do, at equilibrium mole, we know that nothing was given to us. So I'll take stoichiometry, I'll take unity as the initial. See, you can take anything to make the calculations easy. I'll always take unity, right? Okay, if any general derivation they have asked. So 1, 1, 0 is the initial. After that, I know from here x amount is taken out. 1 multiplied by x, 2 multiplied by x is taken out, 3 multiplied x is formed. This is the number of moles. Okay? These are the number of moles because I have solved with the help of stoichiometry. But now, after this, we know that we are calculating concentration. That is number of moles divided by volume. So I am taking V as the volume, capital V. So it will be divided by V, V and V. So I'll just put these values here, 3x by V raised to power cube, right? This is, what is the value of B? What is the value of A? Wait a minute. A is 1 minus x by V raised to power 1. What is the value of B? It is 1 minus 2x divided by V square, right? So that becomes the answer. Now, this is, I have explained here that why we have used number of moles and volume, right? Now, for Kp calculation, same thing will be applied. See, Kp, we use partial pressure here. If I talk about Kp over here, where we have Kp, chalo, I'll just write it over here. Okay? I'll just write it over here. Kp is equals to partial pressure of B raised to power cube divided by something weirdy I have written here. And it should be B here. Chalo, no worries. I have written this formula, so I'll write this thing only. So it will be Pb raised to power cube. This is 4c, that means Pc 4, and this is Pa raised to power 2, right? That was the thing that we know from what is the value of Kp. Now, ma'am, what is the value of Pb? What is the value of Pc? What is the value of Pa? That, ma'am, please tell us. For that, you need to understand this thing, right? That is pressure is equals to, this is the total pressure that will be given to you in the question, right? This is the total pressure that will be given to you in the question. Just like over here, total volume will be given to you in the question only. Here also, total pressure of the vessel will be given to you in the question only, right? Now, partial pressure of anything is equals to mole fraction of that component multiplied by the total pressure. This formula we will study in solutions chapter, right? Now, here I'll just put the same thing here. P is same for all the gases here because it is the pressure of the vessel, right? So here we will say first the equilibrium moles will be 1 minus 2x, 1 minus 4x, and here which is formed, 3x is formed, right? That is the number of moles. Now, I know that here, if you talk about the partial pressure of A, that is number of moles, that is mole fraction. That means firstly I have to derive the mole fraction also. So here, number of mole of that component divided by total moles. Now, what is the value of total moles? Total mole is, I'll just write here, total moles is equals to 1 minus 2x plus 1 minus 4x plus 3x, and that will come out to be 2, this is 4, 5, 6, 6 minus 3, it is 6, 6. Okay, wait a minute, 6 minus, wait a minute. So it will be 4, 5, 6, 6 minus 3, 3x. So it will be 2 minus 3x. That is why mole fraction is number of moles of that component divided by the total moles. Mole of that component divided by total of that component divided by total. Here I have to multiply this by capital P, then only I will get the partial pressure. So this is nothing but this is partial pressure of A. This is partial pressure of C. This is partial pressure of B. Okay. Now I'll just put all these things over here and I will get the answer here and I'll get the answer. The same question has been asked in your JEE, right? Okay, guys. Okay, chalo. Next is, ma'am, what is vapor density and what is DOD, right? Vapor density. Individual questions can be asked here. Just go through the formula because formula is very, very simple here. Formula is actually very simple, right? X is equals to D minus D divided by Dn minus 1. Where if you talk about X is the number of moles only, right? Okay. You can, number of moles, I am saying X is the degree of dissociation only, or you can just write alpha over here, right? Capital D is the vapor density of reactant. If they have given you the molecular weight of reactant, divide that molecular weight by 2 and you will get the vapor density of the reactant, right? Vapor density of the mixture will be directly given to you in the question only, right? N is the stoichiometry of product divided by stoichiometry of reactant, right? For example, I have 2A, 3B. So it will be 3 minus 2. Okay, stoichiometry of product divided by stoichiometry. It will be 3 reactant, product by reactant. 3 by 2 is going to be the value of N here, right? So this is how you will solve the value of N. Just put this in the formula, you will get your answer. Okay, chalo. Next is, okay. Next is they can give you, they can ask you that which of the following is the condition for spontaneous process, non-spontaneous process. So for that, this is the equation that you need to remember, and we will also do the questions based on this in electrochemistry as well, right? So delta G naught is equals to RT ln K equilibrium, right? If you just replace this natural log with log base 10, it will be minus 2.303, right? Now, if you see, if your Kc, that means K equilibrium, right, it is greater than 1. If this is greater than 1, then this term will be negative, right? If delta G is negative, that is a spontaneous process, it will proceed towards forward direction. Spontaneous means it is occurring by itself, it wants to occur, right? If Kc is a negative, this is negative, this is negative, natural log of Kc will be negative, negative will be positive. That means delta G naught will be positive. If this is positive here, if this is positive here, in that case, what you will say, it is a non-spontaneous process and that will occur. Non-spontaneous means it does not want to occur, it will be a backward reaction. If Kc is equals to 1, right, then delta G naught will be 0 because natural log of 1 is 0. Right, so it is basically the condition is for equilibrium and there is no shift of equilibrium here. It is properly like stable, right? Last topic of chemical equilibrium is Le Chatelier's principle, right? Okay, definitely Pranay, that will help you. Thank you, Sandeep. Thank you so much. Okay, chal. Now, Le Chatelier's principle, right? It's a very, very simple principle. Simple questions are asked here, right? Very scoring thing, right? So, I have just put this in a table form so that, not in a table form, I would say in a chart form, so that you don't have to see. Our mind is made in that way. If you have less pages and you have more content, you will be able to remember more, right? As compared to if you have everything is scattered. Okay, so I have everything is compact here, right? So that you are able to learn these things and answer these things in the exam. So first thing is, if you talk about the concentration, so Le Chatelier principle is like that stubborn kid who is like, you tell me to do this, I will do the opposite of that. Okay, it will always do the opposite of what you ask them to do. Okay, I say that I have increased the concentration of the product. You will say, okay, you have increased the concentration of product, I will decrease it and I will move backward, right? If I say, okay, I have increased the, bola tha na. So now if I say we have decreased the concentration of the product you have decreased, you will say, I will do opposite. I will increase the concentration of the product, I will move forward, right? If you say, let's decrease the concentration of reactant, you will say, you are decreasing, I will increase, right? How I will increase? I will move backward and increase the concentration of the product, right? If you say, Okay, let's increase the concentration of reactant. He will say, okay, you want to increase the concentration of reactant? I will do the opposite. I will decrease it. But how will it decrease? How the concentration of reactant will decrease? By moving it forward. In the forward direction, the concentration of reactant will decrease because reactant will be consumed. So that is why I have written here opposite to the increase or decrease in the concentration. Whatever you do, opposite will happen here, right? But if you add any solid component here, there is no effect of that. You increase, decrease any solid component, the concentration of any solid component, that is not going to affect any equilibrium there, right? Next is pressure. So for pressure, a simple thing you need to remember, right? For pressure, when you increase the pressure, it will move towards that particular condition where you have less number of moles, right? So for example, in the forward direction, you have less number of moles. Let's say you have a reactant like 3A give rise to 2B. So less number of moles are in the product side. So when you increase the pressure, it will move on the forward direction. And if you decrease the pressure, it will move towards more number of moles, that is backward direction. But if you have this kind of reaction, now if you increase the pressure, will it move forward or backward? Everybody, right? Okay. Thank you so much, Afsal. Thank you, beta. So now tell me, if pressure I have increased in this particular reaction, will it move forward or will it move backward? Now this is, beach mein I will also ask you questions to know that are you also awake or you are sleeping there, right? Hana? Sitting in the blanket and just sleeping, listening to ma'am as if ma'am is just, giving us some sleeping medicine in the class. Backward or forward? Very good, very good. It is going to go backward because less number of moles are in the backward direction. So according to the reaction, it will change, right? Okay. Next is volume. Volume is inversely proportional, right? It is what will happen in pressure, opposite will happen in the volume case. That means if I say I am increasing the pressure, let's say you say that ma'am, we are decreasing the volume. Decreasing the volume means you are increasing the pressure. And when you increase the pressure, it will go towards number of moles, where number of moles are less. Okay, ma'am, we are increasing the volume. Increasing the volume means decreasing the pressure. Achha, when you decrease the pressure, it will go in that direction where number of moles are more. That means this is also related to this thing. You don't need to cram that, right? Next is temperature. This beta we have done. Do you remember this we have done? I have told you the full concept of this thing, right, with the equation, because from equation also the questions are asked. So if you talk about the temperature here, for exothermic, if you have delta H is negative, in that case, T is inversely proportional to the rate constant, right? And if endothermic reaction, if you talk about, T is directly proportional to the rate constant. That means in exothermic reaction, when you increase the temperature, right, it will move in the backward direction, right? Okay, because rate constant is decreasing, right? If you talk about endothermic, if you increase the temperature, it will move in the forward direction because rate constant is increasing, okay? Next is inert gas. If you talk about inert gas, it does not have any effect at constant volume, but at constant pressure, it will move in that direction where number of moles are more. In that direction, it will move. The reaction will go in that direction where number of moles are more. While when we add the inert gas at constant pressure, right? Now, ma'am, what is this? This is a hint for you that this is exothermic, this is endothermic, usually what they ask, right? So N2 plus H2 Haber's process, right? That is exothermic in nature, right? So that you can answer this thing, right? Contact process, that is SO2 plus O2 give rise to SO3, that is also exothermic. All the combustion reactions are exothermic in nature. But if you talk about N2 plus O2 give rise to NO, that is endothermic in nature, right? Decomposition reactions are also endothermic in nature. Energy is required in that case. Okay, beta, understood? Any problem here? Bachcho, any problem here? Any problem, any problem, any problem? Very good. Chalo. Best revision series? Yes, very good. Thank you, Kuldeep. Thank you. Now, beta, we will move towards ionic equilibrium. Or do you want to do questions firstly? Let's do questions of chemical equilibrium, right? Let's do questions firstly so that our mind can also get refreshed in between, right? Okay, our mind can also get refreshed in between. Like we will do some 10 questions. After that, we will again, no ma'am, no ma'am. Acha, you want to do this only, no questions. Chemical equilibrium questions you don't want to do. Hanji, you don't want to do chemical equilibrium questions, beta. Why I am asking you to do the question side by side? So that it will be easy for you, right? Because just now we have done the concept. Okay, let's do 10 questions. After that, again ionic equilibrium. Okay, let's do questions. Chalo, shabash. Let's do fast. Acha, questions. Okay, equilibrium questions. I have not separated equilibrium, chemical and ionic equilibrium questions. So somewhere there will be ionic equilibrium also. We will see. Right? Now, first question on your screen is the equilibrium constant for the reaction. You have to tell the equilibrium constant for this reaction, everybody. You have to tell the equilibrium constant for this reaction, everybody. Yes, bachcho, equilibrium constant for this reaction. Beta, am I audible? Yes, everybody. Am I audible? Hello, hello, hello. Beta, am I audible? Yes. Beta. Jago, grahak, jago. Sometimes I feel you guys sleep in between the class. Okay. Now, here we have the equilibrium constant for the reaction SO3 give rise to SO2 plus half O2. Kc is this one, the value of Kc for the reaction given below. So, some changes they have done here. We need to see those changes, okay? The reaction is SO3 give rise to SO2 plus half of O2. Beta, first thing is they have multiplied it by 2. Okay, they have multiplied it by 2. So I'll take, if I take this as Kc, so here Kc multiplication is by 2, so it will be raised to power 2. Okay? And also, then they have also reversed it. Okay, if I multiply this by 2, it will be SO3 give rise to 2SO2 plus O2. Now they have also reversed this thing. Hai na? If you reverse anything, it will be 1 by Kc square. That means this reaction is going to have this particular reaction constant, that is 1 by Kc square. So its reaction, its equilibrium constant is going to be 1 by Kc square, right? Okay, so that is going to be the answer. So what is this? This is 1 by 4.9 into 10 raised to power minus 2 whole square. That is going to be the answer. You just need to solve it and you will get your answer. So let's see. After solving this, we will get the answer as, that is 416.49. That is, answer is 416 is the correct answer. Okay, option D is the correct answer. Right. Now, beta, next question is, beta, I am not getting into calculations and all, right? That is your duty. My duty is to teach you what is the concept there. I'll teach you the concept there so that we can quickly sum up this particular series, right? Okay, we need to do so many questions and so many revision here today, right? So that's why let's do it quickly. Now, next is, it will save your time as well. The following reaction occur in blast furnace where iron ore is reduced to iron metal. Now, bacha, what is the answer? This is basically a one-word answer only, right? Based on Lee-Chartier principle. Predict which one of the following will not disturb the equilibrium. Addition of CO2, right? Okay. Removal of CO3, addition of Fe to O3, removal of CO. Very, very simple question, beta. Very, very simple question. Very, very simple. Are Shubha, you are doing na. When you are doing, then no need to be sorry, right? Okay. When you are doing practice, right, mistakes will happen, right? You will learn from your mistakes, right? So stay positive, give the answer whether it's correct or incorrect, but try to answer. Okay, try to answer. At least you will remember that, okay, I answered it incorrectly. Ma'am corrected me. Now I remember what is the correct answer. Okay. Beta, see, this is the solid. And I told you, when you have any solid, right, you add, you subtract, you take out, anything you do with the solid, that is not going to affect the equilibrium. So answer is going to be addition of Fe2O3, right? Addition of Fe2O3, right? So addition of Fe, beta, here I have told you na, in chemical equilibrium, that addition of a solid component, the change in concentration is not going to affect the equilibrium. So answer is going to be C is the correct answer. C is the correct answer. Okay. Next question, bacha. Next question on your screen is, at minus 20 degrees Celsius and 1 pressure, okay, a cylinder is filled, acha, with equal number of H2 and O2 HI molecules for the reaction. Okay. Equal number of H2, I2 and HI molecules in the reaction. The one question, the cylinder is filled with equal number of H2, I2 and HI molecules. That means initially there were molecules. There were moles. है ना? Initially beta there were moles. Right? Now equal number beta. Then Kp for the process is going to be, beta, if you talk about Kp here, first thing is that 2 is over here, this is equal, this is 2 and this is reactant is also 2. So can I say delta Ng is equals to 0. So Kp is equals to Kc over here, right? So you just need to put the value of Kc, right? What is the value of Kc? Everybody, what is the value of Kc? Kc is going to be Hi raised to power 2 divided by H2 raised to power 2, I2, H2 raised to power 1, right? H2 raised to power 1, I2 raised to power 1, right? H2 raised to power 1, I2 raised to power 1. Now, beta, I told you that this Hi, this concentration is basically number of moles divided by volume. They are saying that at this temperature and 1 pressure, a cylinder is filled with equal number of molecules. Equal number of H2, I2 and HI you will have. That means number of moles are equal, that is 1, right? See, number of moles are 1 for all of them, right? And volume, I'll take volume as capital V. Okay, if nothing is given to me, I'll take volume as capital V. This is V. So that means Hi is going to be 1 by V whole square. This is going to be 1 by V. This is going to be 1 by V. They're going to cancel each other and answer is going to be 1. That means Kc is going to be 1 and Kp is also going to be 1. Okay? But beta, don't mark it D. Okay? See the question carefully. Kp for the processes, they have given you Kp is equals to dash multiplied by 10 raised to power minus 1. Okay? Okay? Now, that means if I am saying, if I have to make Kp is equals to 1, then this should be 10 raised to power minus 1, then it will be 1. So that means here it will be 10 into 10 raised to power minus 1, that is 1. So answer will be, this x is going to be 1. Okay, this x is going to be 10. So B is the correct answer. Okay, so B is the correct answer. Got it, everybody? Beta, got it or not? Okay, so that was a nice question. Even after solving everything, chances are students can mark it wrong. In that hurry, they can mark it wrong, right? Okay, so that's why these kind of questions are not difficult. They are tricky. Tricky, that means they are playing with your mind, right? Okay, now next beta, we have the ratio of Kp by Kc for the reaction. The ratio of Kp by Kc for the reaction CO gaseous plus half O2 is this. Beta, just use the formula of Kp and Kc. Just use the formula of Kp and Kc. Beta, just use the formula of Kp and Kc and answer it. Shabash, everybody. A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. Kp is equals to Kc RT delta Ng. Okay. Delta Ng is, bacha, that is going to be 1 minus, product minus 1 minus half. Right. So it is going to be minus half. Okay. So it is going to be Kc RT minus half. So Kp by Kc is going to be RT minus half, na, so it is going to be 1 by under root T, right? So answer is going to be A, right? Answer is going to be A is the correct answer, okay? Huh. That is right, Sachin. Yeah. कोई बात नहीं. We will make our mind so strong that they can't play with us, right? Okay, chal. Now, next is for a given, है ना? Enjoying na? Now just we have done the revision. Now we are doing the questions, right? So you'll be able to see also that, okay, these are ma'am's notes and we can see that questions are asked from there, right? For a given hypothetical reaction, the equilibrium constant as follows. Equilibrium constant, they are saying the equilibrium constant for the reaction X and W. So X to W, you have to do that. That means X to W. X to W. Are you sure there is this Y over here? Wait a minute, guys. Let me just see. Question is wrong. Okay? It should be Y. It should be Y. Okay? Here it should be Y. Okay? Now you can tell the answer here. Right? Now we can tell the answer. If you add, this is 1, this is 2, this is 3. Okay? If you add all of this, you add X, you add these three things, this will be X plus Y plus Z, and this is going to be Y plus Z plus W. Y will cancel each other, Z will cancel each other, and it is going to be X give rise to W, right? That means I'll just add all of them. When you add something, the new equilibrium constant, let's say K4 is going to be 1 into 2 into 4, that is 8, right? So answer is going to be D, right? Okay, bacha, answer is going to be D is the correct answer. Yes, students, D is the correct answer here, right? Okay, chalo. Next is equilibrium. This is shifted to right. Okay, chalo, let's see if you can answer this or not. Not exactly from equilibrium constant, but see if you can answer this or not. Sorry. Yes, beta. Let's see if you can answer this or not. Right? Basically, you must have seen this thing in DNF block. Okay, this is not a question of equilibrium. Let me clear you on that. Right? This is a question from DNF block. Right? Okay, do you remember that? Reactions of KMnO4, K2Cr2O7, if any of you remember, don't get confused here. Right? So this is basic medium. In basic medium, when you have basic medium, the Cr2O7 2 negative is converted to CrO4 2 negative. That is a question of DNF block. I'll just write it here, DNF block. Right? Okay? Chalo. Now, next is, now this is a question of equilibrium. Beta, this is equilibrium only, chemical equilibrium only. The following concentrations were observed at 500 Kelvin for the formation of NH3 from N to H2. Okay, there is N2 plus H2 give rise to NH3, that is the Haber's process. If you mark it right, this will be 3, 2, and this will be the balanced equation. Equilibrium constant, they are asking Kc, beta. Kc is equals to NH3 raised to power 2 divided by N2 raised to power 1. This is H2 raised to power 3. Right? If you talk about the NH3 here, right? If you talk about beta NH3 here, where is NH3? They have given you the concentration. That is 1.5 into 10 raised to power minus 2 raised to power 2 divided by, this is N2. N2 is also given to be 2 into 10 raised to power minus 2. And here you have H2 is also given to be 3 into 10 raised to power minus 2 raised to power 3. right? So you just need to solve this and you will get your answer, right? Okay. Very good, Aryan. Very good. It formed Cr3 positive and acidic. Very good, Aryan. Right? Okay, just solve this and you will get your answer. Right? Okay, calculations you can do after the class. Right? Okay, calculations are better. You will do yourself. Right? And do this with the help of stopwatch or something. If you can do the calculation in the class itself, that would be great. Right? So after calculating, you will get the answer as 417. So answer is going to be 417 is the correct answer. Okay, next question is expression of Kc you have to tell here. Which of the following is right? Bacha, expression of Kc. Expression of Kc. Which of the following is correct here? Expression of Kc. Shabash everybody. Right? So here it should be like this. Okay? So product is FeCN FeSCN raised to power 2 plus 2, right? This is SCN negative, this is Fe3 positive. So what is going to be the answer? Very simple, Shabash beta, very simple. Quickly. Very good, Doraemon has told it, right? Shinchan, Shizuka, right? Hanji, everybody, very good, Havish. Only 2 students have answered it. Such a simple question. Very good, Jai, Chinu, Radha, Shubham, Afsal, very good. Chalo. A is the RN, very good. A is the correct answer. Simply this no power over here, no power over here, no power over here. So this is going to be the correct answer. A is the correct answer here. Right? Okay. Next is, dekho. Do you remember this I told you? This we can do with the help of derivations only. Right? Do you remember this question? I told you, I gave you the derivation also. But in this question, this is A, okay. This is, I think there is some confusion here, right? Equation does not seem to be right to me. Okay. Just give me a second. Right. Okay. It is this equation. Chalo, I'll just show you over here only. Right. Okay. The equation is A give rise to B plus half C. A give rise to B plus half C. This is the equation. Okay. Understood? Now you have to solve this. Now we will solve this with the help of that thing only. That first you will see moles, then mole fraction, then multiply that mole fraction with the total number of moles. So initially I take the initial moles as, let's take n. Okay. Let us see if in the question anything is specified to us. Nothing is specified to us. So I can also take it as 1. Okay. You can take it as anything. Here they have taken it as n. Right. You can take it as 1. You can take it as anything. Right. Okay. That's totally your choice. Right. If you say that, ma'am, please take it as 1, I'll take it as 1 only. Okay. Do you want me to take it as 1? Do you want to take it as 1? Then we'll take it as 1 only. Right. Let's take it as 1. Here it will be 1. I'll just solve it. Right. Okay. Chal. Now, if I take this as 1, this is 0, 0. Right. After that, if I say that some amount of it is taken out. Okay. Let's say x. See, whenever I take, if I take, okay, I'll just give you one thing. Why x is equals to alpha? I'll tell you that over here. If I take x here, that it will be 1 minus x, right? Here, which amount is dissociated, which amount is formed here? X amount is formed. This is 1. This is half, so 1 by 2x is formed, right? Beta, tell me what is alpha. Alpha is the amount dissociated, x divided by the initial. Initial is 1. So that means alpha is equals to x. Right, that means alpha is equals to x. So in most of the cases, alpha will be equals to x only. So you can put it as 1 minus alpha. This is alpha by 2. Okay, that will be the answer. Now after that, these are the total moles. Okay, these are the total moles. Beta, total mole is 1 plus, chalo, those who want to solve it, dekho beta, Mole fraction they have not written na. Koi baat nahi. So we'll just solve it over here, right? Okay. Beta, can we do it like this? Can we just erase it and say alpha over here? Your note should be good, right? So I'll just write it over here. This is 1. This is 1. Okay. This was 1 minus x. This was 1. This was x. X amount is formed. Here x by 2 amount. We know that alpha and x are same. So I'll just write in the form of dissociation only. 1 minus alpha. This is alpha. This is alpha by 2. Total moles. I'll write it here. Total moles is equals to 1 minus alpha plus alpha by 2. That is going to be 1 plus alpha by 2. Right? Here I'll write the mole fraction. Okay? Here what I told you to write the mole fraction here. Mole fraction beta, mole fraction is going to be, everybody, mole fraction is going to be 1 minus alpha divided by 1 plus alpha by 2. Alpha divided by 1 plus alpha by 2. Right? And this is alpha by 2 divided by 1 plus alpha by 2. That is the answer that you will get. After that, I just multiplied this with P. P is the total pressure of the vessel, right? Now we know that what is the value of Kp. Kp is equals to, bacha, that is C raised to power, this is C, okay? This is C. C raised to power 1 by 2, or you can just write it as P of C raised to power 1 by 2 divided by, product is also this one, P of B raised to power 1 divided by P of A raised to power 1. Okay. So we will just put this value here because we know that this is nothing but this is PA, this is PB, and this is PC. Okay, so I'll just put this value here and you will get your answer. Okay, beta, Diksha underscore Kaushal. Okay, got it, beta? Understood? We'll just put the value here and you will get your answer. Understood? Hanji. Now understood now why I told you that is important for you. This is your previous year question only, right? And this does not need any rocket science. It's a very, very simple question, okay? Very, very simple question. Okay. Next is, given below is the statement. They are saying that on passing HCl through a saturated solution of BaCl2 at room temperature, white turbidity is formed. Okay. When HCl is passed through a saturated solution of NaCl, there is a common ion effect. This is basically based on solubility only, right? So we'll do after some time, right? Okay, we'll not do it here. This is also solubility. So ionic equilibrium questions have started. So that's why we'll do these questions after doing ionic equilibrium. Okay, after doing ionic equilibrium, we will do those questions. Okay. Chemical equilibrium beta, we have done the questions as well. Now we will do ionic equilibrium, right? Chalo, ready for ionic equilibrium? Yes, everybody. Are you all ready for ionic equilibrium or not? Chalo. Now, let us start with the ionic equilibrium, what you will have and what you need to study. First thing is to understand that there are two kind of things. First is electrolyte, there is non-electrolyte. Electrolyte is which is dissociating into something, right? There are strong electrolytes, there are weak electrolytes. Strong electrolytes like HCl, they are 100% dissociated. That means if you have 2000 molecule, those 2000 molecule will be dissociated into the ions. But weak electrolyte are, if you have 2000 molecule, maybe out of that 50 will be dissociated, maybe 100, maybe 200, maybe 1000 will be dissociated. So there is dissociation constant is between 0 to 1. Okay. Now that means degree of dissociation is between 0 to 1. For non-electrolyte, there is no dissociation. The examples are like glucose, urea, fructose. These are non-electrolytes. So talking about the strong electrolytes and weak electrolytes, you need to know the examples here. right? If you talk about the strong electrolytes here, strong electrolytes, all the salts are strong electrolytes. They are like 100% dissociated. Strong acids like H2SO4, HNO3, HClO4, HClO3, HCl, HI, HBr, these are strong electrolytes, right? Now, corresponding to this, if you want to know the weak acids, that will be, just take out one oxygen from here, it will be H2SO3. Take out one oxygen from here, it will be HNO2. Take out one oxygen from here, it will be HClO2. Okay, O3 though, because it is over here only. So rest two acids of this, that is HClO2 and HClO, they are under the category of weak acids, that is HClO2 and HClO, right? Then you have HF and HCN, right? Here you have HCl, HI and HBr. HF is a weak acid, right? HCN, or you can say organic acids, right? All the carboxylic acid, these acids are weak acids. Oxophosphoric acid, that means oxo acids of phosphorus are weak acids. Then H2CO3, that is a mineral acid, but it's a weak mineral acid. H3BO3, boric acid, is also a weak acid. They are under the category of weak electrolytes. Talking about the bases here, alkali metal, that is group number 1 bases, the bases that have group number 1 metal, they are strong electrolytes, right? Plus BaOH twice, that means from alkaline earth metal group number 2 hydroxide, only barium hydroxide is strong electrolyte, rest of them are weak electrolytes. So that's why we have written here alkaline earth metal except for barium OH twice, which is under the category of strong electrolyte. Then you have, wait a minute, let me just correct it here. Then you have 1 degree, 2 degree, 3 degree amines, and you have NH4OH, that is a weak acid, that is a weak base. Then you have organic bases like aniline, pyridinium, all these are weak only, right? Okay, okay ji, I have smiled. Okay, now next is Arrhenius. Now beta, these are the concepts of acid base concept. From here also direct questions are asked, simple questions are asked. If you talk about the Arrhenius concept, okay, let's talk about firstly Arrhenius concept. Arrhenius said that acid is that thing which gives H positive in aqueous medium in water, and base is that gives OH negative in water. That is Arrhenius concept, right? Bronsted-Lowry concept is a very important concept, right? In Bronsted-Lowry said that acid is proton donor, but base is proton acceptor. And there are amphoprotic things also. Amphoprotic things means, amphoprotic compounds means that act as both acids, Bronsted-Lowry acids and bases. If you talk about HCO3 negative, it will accept the proton and become H2CO3. Okay? It can accept the proton and become H2CO3. It can lose and become CO3 negative. Both are stable. That means it can act both as Bronsted-Lowry acid and base, right? Okay. Now, what is a conjugate base and conjugate acid? So, when an acid, it donates, or you can say, when an acid, it donates H positive, right? It will form conjugate base. When a base accepts H positive, it will form a conjugate acid, right? Okay. Now, opposite things will happen here. If this is strong, now if something is a strong acid, let's say you have H2SO4. Now, when it loses H positive, right, it will become, if you say H2SO4, let's say HCl, right? And here it will become Cl negative. If this is a strong acid, then this is going to be a weak conjugate base because it would want to gain the proton and become HCl again, right? Okay. So if this is strong, it is highly donating, then it will be like I will be a weak conjugate base, right? Okay. So here you have, if your base is strong, that means opposite will happen in this case. Now, bacha, this is a very, very important concept. That is, if you have CH3COH, any acid you have taken, right, it is going to lose H positive, donate H positive and become this conjugate base. Now, this conjugate base, beta, if you talk about the equilibrium constant of this particular reaction, that is Ka, right? Ka is the equilibrium constant when acid is donating H positive. Now when the conjugate base of this acid, it is in the aqueous medium, it is accepting H positive, that is KBC. That means the conjugate base, right? This is basically for conjugate base, right? It is accepting the H positive, so it is KBC, right? Now it is said that the multiplication of Ka and KBC is equals to 10 raised to power minus 24, right? Okay, minus 24 I am saying, it is 10 raised to power minus 14, right? It is 10 raised to power minus 14. It can also be said it is K raised to, it is Kw, right? So direct simple formula you can write here, right? Okay, okay. Beta, there were different moles only there. Okay, different moles only, right? You can just see the reaction, or you can ask the doubt on Telegram channel. If I teach that again, the frequency of this particular thing that we will lose, right? Okay, so let's firstly complete this. You can ask me individually about that, right? Okay, now if you talk about Lewis acid base, right? Lewis acid is electron deficient, right? Electron deficient species like cations, except for H3O positive and NH4 positive, right? Because they have been found by accepting, lone pair has accepted H positive, that is why you have H3O positive. Lone pair has accepted H positive, that is why it is NH4 positive. So that's why these are not Lewis acids, other cations are Lewis acids, right? Multiple bonds like CO2, SO3, SO2, they are also Lewis acids. Lewis bases are electron rich, right? Like anions or having lone pairs. These are called the Lewis bases. Next is ionic product. If I talk about the ionic product here, that is Kw. Ionic product is H positive concentration multiplied by OH negative concentration, right? Okay, wait a minute, let me just clean the specs. Ionic product of water. Yes, very good beta. Ionic product of water. Chalo. Now, if you see this thing here, that is Kw is equals to H positive multiplied by OH negative, right? At 25 degrees Celsius, Kw is 10 raised to power minus 14. At 62 degrees Celsius, Kw is 10 raised to power minus 13. At 90 degrees Celsius, Kw is 10 raised to power minus 12. What we can observe here, that from this formula, I'll tell you the reason behind this. From this formula, have you seen this formula somewhere? We have written it log K2 by K1 is equals to delta H 2.303 R T2 minus T1 T1 into T2. We have done this formula before also, right? So here we know that if this is a exothermic process or it is an endothermic process. First you tell me beta, water, like, okay, distillation of water, right? It is an endothermic process or exothermic process? Beta, that is a endothermic process. Endothermic process. Because it is an endothermic process, that is the reason as temperature will increase, Kw will increase, right? So that is why as we are increasing the temperature, Kw is increasing here. 10 raised to power minus 14 to it is 10 raised to power minus 13, then it is 10 raised to power minus 12. Because of this particular equation, temperature increases, Kw is also increasing. When Kw increases, H positive also increases. H positive increases means pH will decrease. Why pH will decrease? Because of this formula, that pH is equals to minus log of H positive. If it is decreasing, this will increase. If this is increasing, this will decrease. They are opposite to each other, right? So if H positive increases, pH will decrease, right? Because Kw is also increasing, OH negative will also increase. OH negative will increase, that means POH will decrease. Okay, right? Now, what is pH? What is POH? What is pK? P of this, that, whatever they ask you. Better remember, P of anything in this world, right? P of anything in this world is going to be minus log of that thing. P of Diksha ma'am is going to be minus log of Diksha ma'am. Okay, anything in this world is going to P of anything is equals to minus log of anything, right? Okay. Now, as I can show, as I have shown you here, as this is the formula, H positive, it increases, pH will decrease. So they are inversely proportional. OH and POH are also inversely proportional to each other. And pH plus POH is equals to 14. Reason, because this 10 raised, if you talk about at 25 degrees Celsius, you can also write it here at 25 degrees Celsius. Okay, at 25 degrees Celsius. If nothing is mentioned, that means they're talking about 25 degrees Celsius only, right? So here, because H positive into OH negative is equals to 10 raised to power minus 14, taking the pH here, you will get pH plus pOH is equals to 14 after the derivation, right? Derivation is not required for your competitive exam, so I'm just directly telling you the formulas here. Next is beta, they will ask you the pH of different cases, right? Okay, okay beta. Hanji. Shubham beta, you're asking those pH of earth is equals to this, yeah. Beta Shubham, these questions na, these I can answer you when you take a ionic equilibrium full-fledged lecture of 10 hours, right? Okay, because ionic equilibrium, we also do a lot of derivations there. Right now, I'm just doing the revision, okay? So focus on the formulas and their application, okay? If you have any problem in applying the formula, then I'll tell you that in the questions, right? So if we talk about the strong acids here, there are 2-3 cases here. First is strong acid, like you have HCl, right, H2SO4, right? In that case, always remember firstly, pH is equals to minus log of H positive of solution. H positive of solution we will see individually what is the formula of H positive of solution. So if you have a strong acid, H positive of solution will be H positive from that acid plus 10 raised to power minus 7. And this 10 raised to power minus 7 is from water, right? This is from water. Now beta, 2 cases which are very important for you. First is if your acid concentration is greater than 10 raised to power minus 6. That means acid concentration is giving competition to the concentration of water, then water will be like, I am nothing, I am to 0 in front of this. That is why we will ignore water here. We will ignore the water, that is 10 raised to minus 7 will be ignored, right? That is why the answer will become H positive of solution is equals to H positive of acid is equals to H positive of acid. That's it. But if I say that H positive concentration of acid is very less as compared to 10 raised to power minus 6. Now either it is equal to or it is less than 10 raised to power minus 6. Now acid is like, oh hello, I am the king bro, right? Okay, but then water is like, hello brother, who are you? I am 10 raised to power minus 7, right? So now we will not be able to ignore the water. Then we will use this formula only, right? Okay, same is with the strong base. If you have any strong base, let's say NaOH, right? Any strong base, right? In the strong base case, right, same thing will happen. OH negative is equals to OH negative of base plus 10 raised to power minus 7. If your concentration of OH negative from the base is very large, that is 10 raised to power, it is greater than 10 raised to power minus 6, then you will say that I can easily ignore 10 raised to power minus 7 from water. Water is nothing in front of me. But if it is less than 10 raised to power minus 6 or equal to 10 raised to power minus 6, then we can't do anything with water. Then we have to include water also, right? Then we have to include water also. Ma'am, we should learn all these formulas. Definitely, yeah. If you want to gain marks in the exam, then definitely, yes, beta, you have to learn this. They will not tell you these formulas in the exam, right? Okay, you have to learn this. Acha, if you have 2 strong acids, let's say I have HCl and H2SO4. Okay? Let's say I have HCl and H2SO4. Okay? This is giving 1 H positive, this is giving 2 H positive. So here N factor is going to be 1. Here N factor is going to be 2. Okay, N and M means N factor of that acid or base. The N factor of HCl is 1, N factor of H2SO4 is 2, right? And the H positive of that solution is going to be n M1V1 molarity of acid number 1 multiplied by volume of acid number 1 plus n factor of acid number 2 multiplied by molarity of acid number 2 multiplied by volume of acid number 2. Volume molarity will be given to you in the question. Okay. V1 plus V2, that will be given in the question. V1 plus V2, you just add this. Beta, these questions are very simple. You just need to understand the formula. Otherwise, there is nothing like you say, ma'am, it's such difficult, ma'am, very difficult. Beta, if you see this, what difficulty you can see here? N1, V1, Nm, basically you just have to remember this thing. N1, V1 plus N2, V2 divided by V1 plus V2. What is normality? Normality is n factor into molarity. N into M1. What is normality of 2? N factor into molarity, right? Similarly, we'll do for strong bases. If you have two strong bases, in that case, it will be, let's say you have NaOH, right? And you have BaOH twice. Okay? BaOH, these two are strong acid bases, na? Right? So this is having N factor 1, this is having N factor 2, right? This is having N factor 1, this is having N factor 2, so this will be 1, this will be 2, right? This only you need to know, other things will be given to you in the question. Molarity, volume, right? Normality into volume, N1 V1 plus N2 V2 divided by V1 plus V2. Okay, beta? Tell me, is this thing clear to everybody? Right? N and M are the N factors. Beta, you can do any representation. You can mark it as N1 and N2. You can mark it as M1 and M2. Anything you can mark. I have marked it as N and M. Okay, anything you can do. Right? Okay, chalo. Now, beta, this is very, very interesting. And from here, a lot of, if you ask me, questions are not asked from this one. Very rarely, here questions can be asked. Here question can be asked. Question can be asked from this one, this one, this one, this one. Okay? I have seen all these questions in your previous year, right? Okay, all these questions you can easily see. But this is very rarely, but still I have added it here. This is not asked, right? Okay, but still I have added it here, right? Okay. Chalo. Now, beta. Okay, got it? Wait a minute, beta. Chalo. Clear from all the distractions? Anji. Ma'am, I find thermodynamics hard. I'll give you the tips after half an hour. Okay, once we start with thermodynamics. Okay, now bacha, we have strong acids and strong bases. Strong acids and strong bases. This is very interesting to note down, right? What is interesting? For example, why I have taken here mod? Reason is, if I have N1V1 of acid is greater than N2V2 of the base, right? Then this N1V1 minus N2V2 you will use. If N1V1 of acid is less than N2V2 of base, then you will use N2V2 minus N1V1, right? That means larger value minus the smaller value will happen here. Always, that is why I have taken directly the mod here. You can just apply the mod here, that mod of N M1V1 minus M M2V2. Ma'am, why have you subtracted it here? Can you tell me the answer here? Beta, dekho. Here you had two acids. You wanted to know the H positive concentration in that solution. H positive concentration will come from both the acids. That's why we added it. Here also you had two bases. Concentration of OH negative will come from both the cases. So that is why here OH negative will be from both the bases, right? But if you talk about an acid and a base, if a strong acid is strong base. So for example, HCl has released 100 H positive and NaOH has released 80 OH negative. Now 80 amount of water will be formed. It will be neutralized plus 20 amount of H positive will be left behind. That means we need to subtract them. They are not adding each other. They are neutralizing each other. That's why what we will do, we will directly subtract these two things here. So it will be NM1V1 minus MM2V2, right? Okay, N and M are the N factors. M1, M2 is the molarity, V1, V2 is the volume, right? Now, next is if you have weak acids, right? In weak acids, usually I'll tell you in the exam also how they will neutralize each other, right? Okay. Now, देखो, if you talk about Ka, dissociation constant is going to be C alpha square, right? H positive is equals to C alpha, right? Beta, how I have I'll just explain you here what exactly we have done here. This is CH3 COOH give rise to CH3 COO negative plus H positive, right? Okay, this what we have done. Initially, if I take it as C, it will be 0, it will be 0. Now, after dissociation of alpha, it will be C minus C alpha. This will be C alpha will be formed, C alpha will be formed. So, it will be Ka will be, dissociation constant will be, Ka will be is equals to C alpha into C alpha square. C I will take common over here. It will be 1 minus alpha, right? So, C and C, it will cancel each other. It will be alpha square. This is C. It is 1 minus alpha. Because degree of dissociation for a weak acid is very less, right? That is why it will be equals to approximately equals to C alpha square. That is why we have written Ka is equals to C alpha square, right? Understood? That's how we have written it up, right? Now, H positive, okay? H positive is equals to, beta you come here, na? You only teach here, speed it up, hai na? H positive is equals to this. Then, okay, beta, this is the next page, buffer solution. Salt hydrolysis, right? Then if one is weak, you can do it yourself. Then this, do you want me to teach it like this? Huh? Randomly just saying anything that occurs in our mind. Ma'am, we don't have any knowledge that, ma'am, how to stand here, how to teach, but we will just, anything we can advise, ma'am. Anything, ma'am, we will advise. Achha, where was this? It was over here. ठीक है ना, टू सोल्यूशन स्ट्रॉन्ग एसिड स्ट्रॉन्ग बेसिस वीक एसिड, अच्छा ठीक है, Ka is equals to C alpha square. Now H positive, as you have seen, this H positive concentration is nothing but it is C alpha only. So H positive is equals to C alpha. Acha, what is alpha? What is C alpha? Can you see what is C alpha? C alpha is nothing. If you put the value here, C alpha will be under root C Ka. Can you tell me how it will be under root C Ka? From here you can see that it will be C is equals to alpha square by, it will be, wait a minute. If you put the value of alpha here, let's put the value of alpha. Alpha will be, alpha is equals to Ka by C under root. Okay, if you put the value of alpha here, this will be C under root Ka, this will be under root C. It will cancel and you will have under root C Ka. Right? Okay, that you will have. After that, I'll take the ratio of two weak acids here. Weak acid 1 by weak acid 2, ratio will be this. Right? Okay. Now, from this particular equation, that is H positive is equals to under root C Ka, after taking the pH, after taking the log, then multiplying it by minus, you will get this formula. Beta, this is a very, very important formula. That the pH of weak acid, they will ask you. Mostly they will not ask you this Ka, H positive ratio, nothing they will ask you. They will directly ask you the pH value. pH is equals to half of bracket pKa minus log C. Okay, understood? Yes, everyone? Hanji, understood beta? Is that clear to everybody here? Now, next is weak acid and strong acid. They will not ask you this, but still, okay, but still I have just written the formula here. What if they ask you, just learn this formula. H positive of solution is C2 square plus 4C1 K1C1 plus C2 divided by 2, where C1 is of weak acid, C2 is of strong acid. If there is a combination of one weak and one strong acid, right? Okay, chal. Understood beta? Next is buffer solution. Acha, for buffer solution, what we will have? Everybody, for buffer solution. Beta, buffer solution is which does not change its pH. That is a buffer solution. right? If you talk about the buffer range, that what is the range where it is not changing its pH? The range is from, for an acid, it is pKa minus 1 to pKa plus 1. And for a base, it is pKb minus 1 to pKb plus 1. That is a buffer range. Okay. Now, they can also ask you in the ratio of salt divided by acid or salt divided by base. So, if the ratio of salt divided by acid is between 1 by 10 to 10, that is a buffer range. Or if the ratio of salt by base is 1 by 10 to 10, the ratio is between 1 by 10 to 10, then that is also buffer range. Okay. So, these are the two ways where we can write the buffer range here. Right? Okay. Next is, ma'am, what kind of buffer solutions we will have? So basically, guys, we have three kind of buffer solution. One is acidic buffer, then you have basic buffer, then you have salt buffer, right? So firstly, though, you need to understand what is an acidic buffer. Okay, what is an acidic buffer? So just remember it like this, that weak acid, the salt of weak acid, right, with the strong base, that is a acidic buffer, right? Basic buffer, you will have weak base, right? Okay, and salt, both you will have, right? So basically, this is pH is equals to pKa plus log. I'll just tell you in the next page. pH is equals to pKa for acidic buffer, pKa log salt by acid. For basic buffer, it is POH is equals to pKb plus log salt by base. And for salt buffer, it is half pKw plus pKa minus pKb. That is going to be the answer. So answer is going to be 7 plus half pKa minus pKb. Got it, guys? That is going to be pKb. Hanji. Now, what is buffer capacity? Buffer capacity is number of H positive or OH negative ions added per liter of solution divided by change in pH. Just note down this formula. That is number of H positive OH negative ions added per liter in 1 liter of solution. How much H positive or OH negative you have added and how much amount of pH has been changed. That is called the buffer capacity. Okay, chalo. Next beta, we have hydrolysis, right? Okay. Next beta, we have hydrolysis. Salt hydrolysis is basically, you should have at least one weak component here. Let's say you have weak acid and strong base, or you have strong acid and weak base, or you have weak acid and weak base, then the salt hydrolysis is possible here, right? Now, if you talk about the anionic is basically when you have weak acid and strong base. Cationic is when you have weak base and a strong acid. And cationic and anionic are both, when you say both, it is cationic also, it is anionic also, then it is weak acid plus weak base. Now examples I have given you here. It is formed from NaOH and acetic acid. So acetic acid is a weak acid. So that is why this is a anionic salt hydrolysis. It is formed from NH4OH, NH4OH and HCl. So as you can see, this is a weak acid. It is a weak base. It is a strong acid. It is formed from CH3COOH plus NH4OH. And beta, here both are weak. Weak acid and this is also weak base. Right? This was formed from CH3COOH plus NaOH. That it is weak acid and strong base. Okay. Now, let us see this thing here, beta. If one is weak, now we are saying that if any of this is weak, if one is weak, beta, this is a trick, okay? Everybody, ma'am, I find salt hydrolysis stuff. By this, you will find it easy. Acha. Now, let us see that, okay? Very simply. Okay, we'll just learn this with the help of trick. Okay, what is this trick, right? What is this trick? If one is weak, let's say you have weak acid or you have weak base, right? Either it's anionic or it's cationic salt hydrolysis. Then the trick is that always KH means the equilibrium constant for hydrolysis. That is going to be equals to Kw. Kw is the ionic product divided by K of weak, right? That means H is equals to under root of KH by C. Always H is equals to, H is degree of hydrolysis is equals to under root of this KH divided by C, right? H positive or OH negative, whatever you are trying to find, that will be equals to C into H. Ma'am, what do you mean by this trick? I'll just show you what I mean by this trick. Okay, so if I say I have weak acid, so it will be Kw by K weak. That means Kw by K of A, because acid is weak here. H is equals to under root KH by C. So put the value of KH here. It will be Kw by Ka, right? It will be Kw by Ka, and this is multiplied by or divided by C, right? Okay, same thing I am applying. Now, for a weak acid, I am trying to calculate the H positive concentration. So it will be H positive equals to CH. CH is this, so I'll just put the value here, right? After putting the value, what I'll do, can I say this is nothing but this is C square, so it will be cancelled out, and the answer will be under root C into Kw by Ka. That is going to be the answer. Got it, beta? Everybody tell me, got it or not, right? Okay, yes everybody. Okay beta, हाँ जी. Beta, am I not audible to you? Hanji, ma'am has anger issues. Yes, beta. I really pray to you that you will never get such students, right, who just come here to distract the teacher, right? They don't care about what the teacher has done for them. So I really pray to you that you at least don't become a teacher, right? Okay? Yes, daring girl, have some dare and study, right? Acha, understood na beta this one? Now this is H positive, C under root H we have done here. The same trick I will apply here. Now it is strong acid and weak base, right? Okay. Now it will be Kw by K of weak. Weak is the base, so it will be Kw by Kb, right? What is H here? H is equals to under root KH by C. So it will be under root Kw. What is KH? What is KH? It will be Kw by Kb. So it will be Kw by C Kb, right? So I'll just written it here, right? Now, I am talking about weak base. So I'll be talking about OH negative. So OH negative is equals to CH. CH means it will be equals to C into under root Kw by C dot Kb. If I put it as C square, this will cancel out, this will cancel out, and you will have C into Kw divided by Kb. That will become the answer. So that means you don't have to cram any formula here. Any formula you don't have to cram. Just remember these three things and you will be able to solve this, right? Okay. Now, the last part is to calculate the value of pH. Now, ma'am, see, if you talk about, ma'am, I am very weak in memorizing anything, then I'll tell you, you can take the pH here and solve this formula and derive this equation. But is that required? No. Okay? Because we are in a competitive exam. We need to solve the questions in seconds there. Right? So you have to learn this formula. That is pH is equals to 7 plus pKa plus log C. This is for weak acid. But if you have weak base, in that case 7 is same, minus, instead of plus you have minus half pKb minus log C. Okay, pKb minus log C. That's the formula that you will use here. Next is weak base and weak acid. Beta, why I have not added weak base and weak acid there? Because now the things are changing in this case, right? Now KH is equals to Kw divided by K of weak. Whatever weak you have both things, so you will add both things. Kw is equals to Ka dot Kb. There it was H is equals to under root KH by C. Here H is equals to only under root KH. H is equals to under root KH. That's it. So I'll take the under root here. That will be the answer, right? What about H positive concentration here? H positive concentration is Ka into H. So it will be Ka multiplied by this H here, right? What you will get here, this will be, you can solve it like this, Ka, inside the bracket will be Ka square, Kw, this is Ka multiplied by Kb, this will cancel out and you will have Ka dot Kw divided by Kb, right? Okay, so this is how very easily, see, I know these kind of formulas are difficult to remember, but these things are easy to remember. So just remember these three things and these three things and you are sorted, right? Okay guys, and you are sorted. Got it bachcho? Hanji. Now beta, last topic is solubility product, right? Okay, light has gone, so I'll just pray that light should come in half hour. If there is power cut for a long time, then to beta मैम भूल जाते हैं, then to beta you have to learn, है ना? You can't do anything, you have to learn it somewhere, paste it on the wall, you have to see this regularly, right? Otherwise, ionic equilibrium, physical chemistry is all about formulas and its application, right? Okay, chal. Now bacha, next is solubility product. If you talk about solubility product, simple thing is, two kind of questions are asked here. First is when you take it with the help of common ion effect, when there is no common ion effect, right? So solubility product, first is AXBY give rise to XA raised to power Y, this should be YB X positive. Now what is solubility product? That is KSP is equals to X raised to power X, the value that is on the first product side, that is X raised to power X, Y raised to power Y, S solubility raised to power X plus Y. If I say this is A and this is B, in that case I'll take it as A raised to power A, B raised to power B, and this is solubility A plus B. Okay, that is a short trick of solving the value of KSP of any equation that is given to you. But condition is there should be no common ion effect. If there is common ion effect, then the things will change. Okay, so now if you have common ion effect, then you can't directly apply this formula here, right? Then you have to solve this, right? For example, I am saying in a mixture you have CaF2 and you have NaF. NaF is a strong electrolyte, right? That is the reason it is 100% dissociated. If it is a strong electrolyte, this is 0.1, this is also 0.1, this is also 0.1. That means fluoride ion here is 0.1, right? If you talk about calcium fluoride, this is a weak electrolyte. Here there is no 100% dissociation. So this is Ca2 positive, this is F negative. Initially I am taking solubility as S. Initially it is 0, 0. We used to take concentration C, na? Here we are taking solubility S. Now we are saying that all of this is consumed, all of this is getting soluble, so it will be 0, this will be S, this will be, wait a minute, this will be 2 now, so it will be 2S, okay? It will be 2S, right? It will be 2S. Now, why I have added 0.1 here? Because NaF also is giving you 0.1 fluoride ion, right? This is 2S. So that means F negative is F negative only, na? Whether it's from NaF or it is from CF2. So that's why I have added S over here and I have added 0.1 over here to make these two things equal. Here I'll add 2S. Instead of this, I'll add 2S over here, right? Okay, not S, right? Okay. Now, solubility is very small. That is the reason, because solubility is very small as compared to 1. That is why we will just ignore this thing. And that will be approximately equal to 0.1. And now, if you solve this thing, KSP is equals to, product is solubility. Here you have stoichiometry 1. Here you have stoichiometry 2. So it will be 0.1 raised to power 2. And this is going to be the answer. Got it? That is for common ion effect. Right? Okay, beta. Last is number of ions. After this, we are going to solve the questions. I think, Sachin, you prayed and light power cut is like light is there now, right? Electricity is again we have in this room, right? So congratulations to all of you, right? Otherwise, so I was thinking that the lecture might not go for a long time, right? Thermodynamics, I'll just, in my head, I was thinking that, oh God, that means now I'll, the promise, you know, I promised you to complete today thermodynamics as well. And I was like, okay, that means thermodynamics I won't be able to complete, but now I can see that I'll be able to complete that, right? Now, beta, number of ions, same or different. This is again a very simple concept, right? They can ask you the, which of, they can give you 3-4 examples, right? For example, they have given you, let's say NaCl and AgCl. Okay? This is what they have given you. Now they have given you that KSP of NaCl, this is 1, this is KSP 2. They have given that KSP of 1 is greater than KSP of 2. Then what will be the answer for solubility? Beta, when you have same number of ions, here you have Na positive, Cl negative, Ag positive, Cl negative. So number of ions are same, right? Number of ions are same. If number of ions are same, then solubility is directly proportional to the KSP. That means S of 1 will be greater than S of 2. That means precipitate formation of 1 will be less than precipitate formation of 2. If the number of ions are same in that case. If the number of ions are not same, let's take an example. You have NaCl and you have MgCl2, right? Here, beta, they have given that again KSP of 1, this is KSP of 2, just an example. They are saying that KSP of 1 is greater. Now you have to tell the solubility also, the precipitate formation also, right? We know that the number of ions here are 2. Number of ions are 2. Here the number of ions after dissociation will be 3, right? KSP is inversely proportional to PPT. So I can say that PPT formation of 1 is less than PPT formation of 2, precipitate formation of 2, right? That is inversely. But when you have same number of ions, in that case, solubility is directly proportional to KSP. But when you have different number of ions, in that case, solubility is not dependent on the KSP, it is dependent on the number of ions. So we can say that solubility of MgCl2, solubility of MgCl2 is greater as compared to solubility of NaCl. Even though NaCl has more KSP, but the solubility of MgCl2 is greater because it has more number of ions, right? Okay. Yes, students, is that clear? Yes, students, beta, is that clear to everybody? Now let us solve the questions of ionic equilibrium. Okay, let's solve the questions of ionic equilibrium. This was the question of ionic equilibrium, right? Let me see how many questions we have. Not that many questions, right? But still good amount of questions we have, right? Okay. Chalo. Now let us solve the questions, guys. Everybody in the comment section. Everybody in the comment section. Let me know in the comment section. Question time starts. Okay, ready for questions? Chalo, everyone. Given below are two statements. So two statements, guys, they have given you, right? Okay. Two statements are given to you. On passing HCl through a saturated solution of BaCl2 at room temperature, white turbidity appears. When HCl gas is passed through saturated solution of NaCl, sodium chloride precipitated due to common ion effect. Okay. ठीक है. So basically guys, if you talk about this thing here, everybody let me know in the comment section which of the following is correct. Hmm. Both are true, na? So if you see, on passing HCl through a saturated solution, BaCl2 at room temperature, white turbidity appears. That means it is getting soluble, but after adding, on passing HCl through the saturated solution, BaCl2, otherwise it is soluble, but on passing it, white turbidity will appear. That is the true statement, right? If you talk about when HCl is passed through a saturated solution of NaCl, NaCl saturated, which is soluble, you pass it there. Sodium chloride is precipitated due to common ion effect, right? Because of common ion effect, you have NaCl, you have HCl, right? Cl is the common ion. That is why sodium chloride is precipitated out due to the common ion. Basically, when you add HCl, BaCl2 and BaCl2 and NaCl, which were earlier soluble, right? The inhibition will be caused by the HCl. So both the statements are the true statement. BaCl to NaCl soluble, but on adding HCl to this and NaCl, sodium or barium chloride may precipitate out due to the common ion effect, right? Okay, so both the statements are true. Acha. Next is, a buffer solution is mixture of salt and an acid or a base mixed in any particular quantities, right? Blood is naturally occurring buffer solution whose pH is maintained by H2CO3 and HCO3 negative. Yes, students, everybody, which of the following is the correct statement? Right? Okay, Hanji. A buffer solution is mixture of salt and acid. Buffer solution, salt and an acid or a base mixed in any particular quantities. Hanji beta, any particular quantities. Any particular quantities thodi will make the buffer. There should be a specific quantity, na? Only then you will have the buffer, right? Okay. So first is going to be false. Then there is blood is naturally occurring buffer solution whose pH is maintained, right? So that means this is the correct statement, right? pH is maintained by H2CO3 and HCO3 negative. So answer is, first is false, B is true. So statement 1 is false, B is true. That means C is the correct answer here. Okay. So C will be the correct answer. Wait a minute. C will be the correct answer here. Right? Okay. Chalo. Next question is, for a sparingly soluble salt of Ab2, there is a salt Ab2. The equilibrium concentration of A2 positive ions and B2 negative ions are this. The solubility product they are asking you. So, beta, you have Ab2, right? They will give rise to A2 positive plus B negative. This thing they will give rise to. Now, bacha, just tell me what will be the answer. KSP you have to find out. You were right. Very good. Beta, KSP you have to find out. How you will find out the KSP? Okay, this is 1 raised to power 1, 2 raised to power, there is no common ion effect, so directly applied. Solubility of 1 plus 2, so that will be 4s cube, that is KSP. But have they given us the solubility? First, we have to see that. Okay, this and this respectively, the solubility, the concentration, there is no use of doing this because the concentration are given to you. Okay, if the solubility, if they would have given us the solubility, in that case, I would have used this particular formula. But because beta, the solubility is not given to me, that's why what I'll use, I'll just directly use KSP equals to, this is B negative raised to power 2, A2 positive raised to power 1. Okay, so concentration is what? B negative is what? B negative is 0.24 into 10 raised to power minus 3 square multiplied by, what is A2 positive? 1.2 into 10 raised to power minus 4. Right? Now you just solve this equation, right? And you will get your answer. Okay, students, just solve this equation and you will get your answer. Let us see. After solving this equation, you will get the answer as this, that is 6.91 into 10 raised to power minus 12. So answer will be A is the correct answer. Okay, answer will be A is the correct answer here. Next question is Ka for CH3COH is this, Kb is this, the pH of ammonium acetate solution. Beta, ammonium acetate solution, NH4 acetate na, NH4 acetate, wait a minute, ammonium acetate solution, right? Okay. Chalo. Ammonium acetate solution you are forming. Ka you have, Kb you have. Okay, both are weak. This is weak acid. This is weak base. Okay, they are asking you to find out the pH here. Yes, students, the pH formula. Hanji beta, hanji. So pH, just use the pH. Ka is given to you, Kb is given to you, Kw you already know, right? So just use the formula, right, and you will get your answer. pH is equals to pKw plus pKa minus pKa divided by 2, right? Use this formula, right, and put the values and you will get your answer, right? Okay, so after using this particular formula, dekho beta, Ka of this is 1.8, this is also 1.8, that means Ka is equals to Kb. If this is given to you, you will just put this value here, Ka is equals to Kb, that will be cancelled out, this will be cancelled out, so answer will be pKw by 2. pKw, what is pKw? Is nothing but 14 divided by 2 is 7. So it's a very, very simple question. Okay, so there is no calculation required here, right? Okay, next is given below are the statements. Aqueous solution of ammonium carbonate is basic. Beta, aqueous solution of ammonium carbonate, shabash everybody. Everybody, aqueous solution of ammonium carbonate is basic. Okay, acid basic nature of salt solution of a salt of a weak acid and weak base depends on Ka on and Kb value of acid and the base forming it. Yes beta, yes beta, hanji. Aqueous solution of ammonium carbonate is basic in nature or not? It is basic in nature or not? Aqueous solution of ammonium carbonate beta. Hanji, ammonium carbonate is basic or not? Then you have acid and basic nature of salt solution of salt. First statement is true, that is basic in nature. Ammonium carbonate, right? That is basic in nature. So that is a true statement, right? Then acidic basic nature of salt solution of a salt of a weak acid or a weak base depends on Ka on Kb value of acid and base forming. So definitely it will depend on the Kb and Ka value, right? If you talk about weak acid and weak base, right? In acid and weak base of a weak acid and weak base, right? So that will definitely depend on that, right? Okay. So answer is both are true. So statement 1 and 2 both are the correct statement, right? Okay. So theory based questions, basically they want to know your concept here, hai na? So pH at which MgOH twice begins to precipitate forms a solution containing 0.10 0.10 molar of Mg2 positive ion is. Beta, this is a question of, wait a minute, the pH at which Mg2OH twice, KSP is given to you. Okay? Begins to precipitate from a solution containing this much Mg2 positive ions. Concentration is also given to you for Mg2 positive. Okay, concentration is also given to you. Yes, bachcho. Hanji. So if you talk about the pH, they are asking you, begins to precipitate. So when there is precipitation, in that case, we can say that just like in at equilibrium, QC is equals to KC. In similar in this case also, QSP is equals to KSP. right? Okay, so this is at any temperature, this is at any reaction condition, this is properly when the solubility is happening, Ksp, right? So when precipitation become, these two become equal, right? Okay, so you can say that Ksp is any value at any condition, right? So this is MgOH twice, that is going to be Mg2 positive plus 2OH negative, right? Any condition we know that it is OH negative raised to power 2, Mg2 positive, right? Ksp is given to me, that is 10 raised to power minus 11, or you can say 1 into 10 raised to power minus, I'll just directly write 10 raised to power minus 11 here, right? Now they are saying the pH you have to calculate. You can firstly calculate the value of OH negative from here. OH negative square is equals to 10 raised to power minus 11. This is Mg2 positive. Mg2 positive is given to be 0.10, that is 0.1. You can say it is 10 raised to power minus 1, 10 raised to power minus 1, right? Okay, minus 11 by minus 1. So it will be 10 raised to power minus 10 OH negative square. So OH is going to be 10 raised to power minus 5, right? Just write it here. OH is going to be beta, 10 raised to power minus 5, right? Take the under root there, it is going to be 10 raised to power minus 5. It is square, it will be 10 raised to power minus 5. So pH, okay, taking the log here, that is minus log, it will be 5, right? Okay, it will be 5, 10 raised to power minus 5, it will be, answer will be 5. If pH is 5, POH is 5, this will be 14 minus 5, that is 9. Okay, so pH is going to be 9. Okay, so pH is going to be 9. Right? Okay, bacha. So pH is going to be 9 here. That is going to be the correct answer. Chalo. Done, 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 done. Now, beta, we will see thermodynamics. Thermodynamics. Let's see that. Acha, I want to know, do you want to do thermodynamics today, or do you want me to take up lecture on Sunday for thermodynamics? Hanji, everybody, do you want me to do thermodynamics today itself, or do you want me to take up the lecture of thermodynamics on Sunday? Totally your choice, right? Totally your choice, right? Okay. If you want to have a like fresh mind on thermodynamics, we can also do it on Sunday. I am available on Sunday, right? Okay. I'm completely available on Sunday, right? Today, Sunday, okay. Beta, Namrata ma'am is going to take class today at 9 p.m. That's why I'm asking you, will you be able to take maths class after this or not? I can do it today, है ना? It will not take that much time. Hardly 1.5 hour more it will take, right, for me to complete it today. Okay? Huh. If you want me to do it today, write TTTTT. If you want me to do it on Sunday, write SSSSS. Okay? So Harish is saying today 1. Let's give the votes here. Okay, Afsal Sunday, JE Sunday, Spartan Sunday. ठीक है, Harish today, Nature Backup Sunday. अच्छा, Sunday you guys are saying ना. तो Sunday, tell me which time. SSS ना, mostly I can see SSS only here. Ma'am, more questions on equilibrium. तो यार, I have these many questions only today तो. ठीक है, चलो, we'll take question part. I also take question part individually. Okay, don't worry about that. Right? अच्छा. I think Harish is only saying T. Rest of are saying S. ठीक है, चलो. So I'll take it on Sunday. Okay, I'll take it on Sunday because half of this we have completed, half of this we are still left with. Beta, morning slot, 8 p.m. Nana, 8 p.m. will not be possible. You can take some slot like maybe 4 p.m., 3 p.m., something like that. Right? Okay? Okay? Hanji. Beta, morning, what do you say morning? Morning for you is 10 a.m. or 11 a.m. अरे यार, it's my Sunday यार, let me sleep at least, let me have a good sleep at least on Sunday. ठीक है? Morning too early. So let's do it at okay, the time on Sunday, let's take the class. Shall I take the class at 4 p.m.? 4 p.m. works? 4 p.m. or 3 p.m.? 8 p.m. beta, it will be too much for me also. है ना? Personal life also beta I have. है ना? Family also I have. है ना? So I can't tell my family even on Sunday I am not available for them. Na? My parents will be like, she don't only sit with us and talk to us what we have done. है ना? So, tell me on at what time? 3 p.m. 3 p.m. or decide between 3 p.m. or 4 p.m. 3 p.m. or 4 p.m. decide between these two. And I want all of you to be there. Right? 3 p.m. I think by 3 p.m. we'll be able to finish it by 6 p.m. You all will be free. Okay? You all will be free by 6 p.m. Hardly it will take us 2 hours to complete thermodynamics. Right? Okay? Because already I have written the notes. Right? Even if we do it in detail, also then it will take us hardly 2 to 2.5, not more than that. Right? So 3 p.m. Okay? 3 a.m. 3 p.m. yaar. 3 p.m. Okay? So Sunday at 3 p.m. I'll just schedule the class now for thermodynamics. Okay? For thermodynamics, because I can see because equilibrium is itself a very twisted chapter, right? So I can understand that you also must have been like, ki ma'am, we are totally, we don't know ma'am. है ना ma'am, now we have just done chemical and ionic equilibrium, ma'am. Thermodynamics will be too much. After that you have your maths class also. So I feel that will be too much for you. है ना? So that's why Sunday time is 3 p.m. We are going to take thermodynamics. Okay, ji? We are going to take thermodynamics. That is clear to everybody? Beta, Prakat, beta, we have already done inorganic chemistry. You can go and watch the live section. Right? Okay? Yes. Spartan, around 4 p.m. I'll start the question part. Okay? Ma'am, question only I want to do. Okay? So around 4 p.m. I'll start the question part, but the rest of that will be this thing. Okay? I don't know. The mic is itself saying that I am tired. Chalo. Now, everybody, bye-bye. Take care. The class is completed. Now we will do thermodynamics on Sunday at 3 p.m. Right? Tell this to all your friends. I'll just schedule the class by tomorrow. Right? I'll send you the link on the JE channel so that you should know that, okay, this is the link where the class is going to happen. Okay? Chalo. Okay, bye bye. Take care. But before going, one thing very, very important for you, that is because beta holiday sale has been extended till Sunday, that is 5th of Jan, right? So that's why a lot of offers are there on Crash Course Pro, Crash Course Prime, Crash Course Combo, Crash Course, and also if you want to purchase the JEE Means and Advanced Test Series, right? Okay, because beta practice, you are saying na, practice will be done with the help of test series only, right? Okay, so only theory, nothing will happen with only theory. So you also have to do a lot of practice. So practice will do with the test series, right? So you will get 20 full length test series for JEE Mains, 10 full length test series for JEE Advanced, subject specific mock test to stimulate real life, exam capabilities, right? Those will be extended. Now that is just for 1333, right? That is holiday sale, right? Okay, so holiday sale is going on approximately at 50% off. You're getting it, right? It is only valid till 5th of Jan, so you can just go and purchase it. Okay, yes. Okay, bye bye. Take care. See you all in the next class that is happening on Sunday at 3 p.m. In the comment section also write thermodynamics 3 p.m. Sunday. Okay, bye 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 bye.